All right, good morning, everybody. Good morning. Did everybody have a good weekend? Yes? All right, so today we're gonna just go over some things from last week, and then we're gonna jump into new content today. So just some housekeeping rules. Please put your phones and devices away, okay? Also, I sent out a remind and an email through Canvas to submit your work. Okay, you did not have a lot of stuff to do in here last week. Most of it was housekeeping stuff. You need to stay on top of your work. So I gave you an extension. It was supposed to be due Friday. I extended it till Sunday. If you still do not have it done, it needs to be completed by today. Okay. Next thing, we're going to jump into some notes today with some content. Today's content is pretty basic. We're going to talk about the Big Bang Theory, but what I want you to do is pay attention to me, because since we have to upload videos for those that aren't in class this week, our videos have to be a certain amount of time. So I'm going to go over stuff, you're going to pay attention to me, and then when I set you loose, you can go back and fill in your notes with the PowerPoint that I uploaded to Canvas. Does anybody have questions about that? That way you can ask questions as we go through the PowerPoint. And then if you have questions later, I will also answer them. Okay, we good? Yes? Everybody good? All right, so today we are going to talk about the Big Bang. Does anybody know what the Big Bang is? Is it better lights out or on? Out? Okay. All right, so anybody know what the Big Bang Theory is? Anybody ever heard of the Big Bang Theory? Hello? Hi. No? All right. So this is our introduction to astronomy. Does anybody know what astronomy is? Or what it might deal with? Okay, so we're talking about space and everything that we find there. What are some things we find in space? If you were to go outside on a nice clear night, what might you see in the sky? Shooting star, the moon. What else? Okay. What? Anything else come to mind? Asteroids. Anything else? Stars. Anybody got anything else? What do we live on? Earth. Earth, so what? A planet, okay? So we're going to talk about a lot of these things. So today, we're going to talk about briefly the history of astronomy, okay? So the Greeks had what was known as a geocentric view. So always, 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 if you do not know what a word is, pull out, and I've told you this before, pull out the root word, the prefix, or the suffix to help you figure out what it might be so that you can make an educated guess if you don't know. So what word do you see here that might help you figure out what this is? What's at the beginning of the word? Geo. Do you know any other words that have geo in them? Yeah? What? Geology? Is that what you said? Geometry. Okay, geometry. Geology, I just gave you another one. Geometric. Okay, geography. So this will help us figure out what it is. So geocentric is when they thought that the Earth was a sphere, and a sphere means that we're a what? What's a sphere? A ball, a circle, right? Okay, so they thought that the Earth was a sphere that stayed motionless at the center of the universe. So this is a picture of what the Greeks thought the geocentric view is, okay? So Earth is at the center of the universe and everything revolves around it. Next, we have the first Greek to believe in the heliocentric model. Okay, so now we're going to take out some more words. So helio. So the heliocentric model was that the Earth and other planets orbit around the sun. So instead of the Earth being the center, now the sun is the center. Okay? So modern astronomy started with someone by the name of Nicholas Copernicus. Okay, so here is the heliocentric model. So sun-centered. And geocentric is Earth-centered. So Earth versus sun. So what is a heliocentric system? So Copernicus proposed a heliocentric view of the solar system in order to explain the motion of the planets. Okay, so what is in the center of heliocentric? The sun, okay? So here's just another picture of what that looks like. Okay, and then that tells us that the sun is in the center, and what are these that are going around it? The planets, okay? So the current understanding of how the universe began is known as what is called the Big Bang Theory. Anybody ever watched the show that deal about the Big Bang? No? All right. So it wasn't big, and there definitely wasn't a bang, okay? But this is what they proposed is the Big Bang. So there was an explosion, and then once the explosion happened, there became an expansion. So we're going to watch this YouTube video just to give you a little idea of what the Big Bang actually is.
I'm Jana, and I'm a professor of physics and astronomy. I work on where it all started. The simplest picture of the Big Bang starts with nothing. There's really nothing. There's no space, there's no time, there's no matter, there's no energy. It's nothing but the potential to exist. And out of that bursts the universe. Time starts, space is created, all of the matter and the energy in the universe is born at that moment. In the first minute fraction of a second, the universe inflates. And then about 3 minutes later, atoms begin to form. And about 5 billion years later, galaxies begin to form. One of these galaxies, about 10 billion years later, a little ordinary planet forms. And 14 billion years later, people evolved. We're at the last week in the cosmic history. Big Bang is often misunderstood as an explosion in space, because the space existed and time existed, and there was just this explosion of matter and energy into space. But something much more profound than that is going on, and that is space itself is created in the Big Bang, and time is created in the Big Bang. The Big Bang describes the origin of the entire universe. But we also know that the math that we're doing on pen and paper isn't going to be the whole story. It's possible that the universe was really a bounce from a previous history when the universe was already big and started to collapse and bounced out into a new Big Bang. And then we were born in this cosmos that we think started 14 billion years ago, but really it goes back infinity to infinity, an eternity of bounces and cycles like this. Or it's possible that our universe is just one kind of bubble or plume off of a patchwork of other bubbles and plumes. And so there's other universes out there. It's like a megaverse, but we can't contact them. So for all we know, this is it. This is the whole cosmos, back to our beginning and our Big Bang. But it might not be that way. But we know something happened, something that created a hot space from which the universe expanded and evolved.
Does anybody have questions about that? So 2 words, what would we use to describe the Big Bang? What happened first?
The beginning of everything.
Explosion.
The Big Bang.
And then what happened next?
The idea that the universe was suddenly born and is not infinite. Up to the middle of the 20th century, most scientists thought of the universe as
What happened next after the explosion? Say again, Jason, I can't hear you. Development, okay, so what's the word we use though? What is it doing? Expanding, okay? So, expanding. So now we added space and we added time, okay? So the theory of the Big Bang actually states, okay, that the universe began from an initial point, okay, so there's one single dot, and it expanded over billions of years to form the universe as what we know today, okay? So, the Big Bang, one little dot, one single point, an explosion occurs, and then it expanded. So, what's happening to the universe now? So the universe we live in is considered expanding. So that means that it's getting larger and larger. Okay? We know this because we see galaxies and groups of galaxies that are steadily moving apart in the universe. So this expansion has been occurring since the universe was formed 14 billion years ago. Okay? Billion, that's a lot. So there's what is known as the Doppler effect. Has anybody ever heard of that? Do you have any weather people in here? So the Doppler effect, okay, is talking about redshift and blue shift. So the stars are moving away from an observer, they appear red. So if they're going away from you, they appear red. If the stars are moving toward you, okay, those appear blue. So if they are red, they're going further. So you see that here, okay? Those waves are further apart. And in the blue shift, they are shifting toward you. So you see that the waves are much more closer together, okay? So at the top, you can see unshifted. In the middle, you can see red shifted, okay? And at the bottom, you can see blue shifted. So the red shifted is shifted which way? Well, which way? So it's shifted away, okay? And the blue shift towards you because it's much shorter, okay? Does anybody know what this is called when you see these colors? Anybody ever heard of the electromagnetic spectrum? Okay, and the different ways of light. Okay, and then we call that Roy G. Biv. What's Roy G. Biv? Rainbow. Colors of rainbow, right? You know what they are? Yep, red, orange. Close. So the I is indigo. Indigo, violet. Okay, blue, indigo, violet. Nicely done. All right. So the Doppler effect. There's a change in wavelength of a wave from a source as it moves away from or toward an object. So if it's going away, that's the red shift, and if it's coming towards, that's the blue shift. So red, the wavelengths are getting bigger, okay? And in the blue shift, the wavelengths are closer together. So when a light source is moving towards the observer, the wavelengths shorten, which I just said, and when they move away, they lengthen, so they get longer. So the next piece is the nebular theory. Okay, so the nebular theory is the theory of how star systems were formed. So this is when you go out a nice clear night and you see stars in the sky. Okay, this is the most widely accepted scientific explanation of how stars came to emerge from the cosmos. So the big piece to know about the nebular theory is that they are gaseous clouds, so big balls of gas. So they are known as nebulae. That's just the plural form of nebula. So they slowly rotate, gradually collapse, and flatten due to gravity, and eventually form stars or planets? What's gravity? Okay. Like a pool. So what does gravity allow to do? Okay, it can. Anybody else? So gravity is what allows also things to be in space, right, where they're at. So big piece, gaseous clouds, big balls of gas. So then there's also what is known as the solar nebular theory. What does solar mean? What do you think of when you hear solar? So sun. When I hear solar, I think of sun, and I think of heat, right? Solar, okay? So all solar systems start as clouds of gas, so those balls of gas, and dust that are known as the nebulae, or nebula, okay? So gravity and what is known as the centrifugal rotation compress dust into objects like stars, moons, and planets, okay? So we take those clouds of gas and dust, and then they form the stars, moons, and planets. So those are the things that we see in the sky. So up here, the Earth revolves around the sun. What's that called? If it's sun-centered? What is it when it's sun-centered? Oh man! I know it's Monday morning. Helio what? The sun is in the center. Heliocentric, okay? So then we have the solar system revolving around a galactic center. So now if we talk the opposite of being the center, the sun being the center, and the Earth being the center, what is that called? Begins with a G. Geocentric, nicely done. So galaxies move away from each other in an expanding universe. So the big takeaways from today, we need to know what the Big Bang is. So it started off as a what? Just a single point, right? And then what happened? Explosion, and then it began to expand. And then we need to know the difference between blue shift and red shift. So blue shift goes which direction? Towards us, and it gets what? Smaller, shorter, okay? And red goes away, and it gets bigger, okay? And then a nebula is a big cloud of what? Gas. Boom. All right. So the difference between the solar system, galaxy, and the universe. So between these three, size is the biggest distinction. So we live on planet Earth, which is part of our local solar system. Does anybody know any of the other planets? We're going to talk about those tomorrow. And what one's not a planet anymore? Pluto. Nicely done. Okay. So our solar system includes the sun and then everything that orbits around it. So that's our heliocentric model. So our sun is just one star in the Milky Way galaxy. So the Milky Way galaxy is just one galaxy in the entire universe. Okay? So which one would be the smallest? We're talking about size being the biggest distinction. So our solar system includes the sun and everything that orbits the sun. Our sun is a star that's in the Milky Way galaxy, and then the Milky Way galaxy is just one galaxy in the universe. So let's start the other way. What's the biggest? The whole what? The whole universe. And then what do we find in the universe? A bunch of what? Galaxies, okay? And then we find in the galaxies a bunch of stars, and then the sun in specific, a star, is in the center of the solar system. So does anybody have any questions? Okay, so we need to know the Big Bang. We need to know red shift, blue shift. We need to know the difference here, okay, in sizes between the solar system, galaxy, and universe. Everybody's good. And a nebula. Big gas clouds. All right, so what I'm going to have you do, you are going to log on to Canvas, and in Canvas you can either go to your daily announcement, has what you should be working on today, or you can go to your Unit 1, and that will take you to your little calendar that will show you what you're working on today. So the first thing you're going to do is go back through and fill in your notes. So now that you've heard it from me, you're going to hear it again, going through it yourself. Then once you finish that, there's an Ed puzzle, okay? So we need to make sure that we work on that. And then once your Ed puzzle's done, you have a web quest, okay? Any questions? You good?